Let's consider the following scenario. Suppose you make a 20-ounce glass of Arnold Palmer by mixing 13 ounces of iced tea with 7 ounces of lemonade. I'm going to do a little bit of abbreviating here. I'm going to write AP to represent the number of ounces of Arnold Palmer in this mixture, which we know is 20. I'll use T to represent the number of ounces of iced tea in the mixture, which is 13. And then I'll use L to represent the number of ounces of lemonade in the mixture, which is 7. So knowing how many ounces of each of these things we have, we can say a lot about this mixture. So for example, the total number of ounces, or the number of ounces of Arnold Palmer, is 20 divided by 13 times as large as, I'm going to abbreviate times as large as to TALA. So the number of ounces of Arnold Palmer is 20/13 times as large as the number of ounces of iced tea, T. We could also say that the number of ounces of Arnold Palmer is 20/7, 20 divided by 7, times as large as the number of ounces of lemonade. We could say a few more things like the number of ounces of iced tea is 13 divided by 20 times as large as the number of ounces of Arnold Palmer. We could say the number of ounces of lemonade is 7/20 times as large as the total amount of Arnold Palmer, and so on and so forth. We could actually make a couple more statements relating the number of ounces of iced tea and the number of ounces of lemonade. So there's a lot of different things we can say in this situation just knowing these values. So let's extend this a little bit. Suppose your friend wants to make some Arnold Palmer that tastes exactly the same as yours. So the ratio of iced tea to lemonade should be the same in her mixture. So first let's assume that your friend wants to make 32 ounces of Arnold Palmer, which in this case, the number of ounces of Arnold Palmer in her mixture is going to be 32. And suppose we want to know how many ounces of lemonade and iced tea she needs to use. Previously, we said that the number of ounces of iced tea is 13 divided by 20 times as large as the number of ounces of Arnold Palmer. And therefore, in this scenario, the number of ounces of iced tea that she should use is going to be 13 divided by 20 times as large as that 32 ounces. On the other hand, we can say that the number of ounces of lemonade is 7 divided by 20 times as large as the number of ounces of Arnold Palmer, and therefore for our friend's mixture, the number of ounces of lemonade she needs to use needs to be 7/20 times as large as that 32 ounces. And both of these gives you some value, but I'm not totally concerned with computing those. You could just plug those into your calculator. Okay, let's put another twist on this. Now let's suppose your friend wants to use 20 ounces of lemonade in her Arnold Palmer mixture. So in this case, we have 20 ounces of lemonade, so L is going to be 20. Now, we could say that the number of ounces of Arnold Palmer is 20 divided by 7 times as large as the number of ounces of lemonade, based on our original mixture. So previously we saw that in the original mixture, we had 20 total ounces of Arnold Palmer, 7 ounces of lemonade, so we can make this statement right here. Now the implications of that are, in our friend's mixture, the total number of ounces that she makes is going to be 20 divided by 7 times as large as the number of ounces of lemonade that she uses, and so it'll be 20 divided by 7 times as large as 20. And that'll give us some value, which you can plug that into your calculator to compute it, but we can determine exactly how many ounces of Arnold Palmer we're going to make, and similarly, we could do a similar process to determine how many ounces of iced tea we need in this mixture, just based on how the iced tea and the lemonade are related in the original mixture.